All right, guys, going to get started. I'm going to start with the homework, and then I have like one problem I want to do on the review. All right. And honestly, all tests and quizzes, they're pretty heavily based on the homework. If you guys are doing the homework, you'll be fine for the test. So the problems I'm doing, I wouldn't just rely on those. Make sure you do the rest of the homework, understand the rest of the problems to make sure you do really well on this test. All right. So this problem, number 17, I want to complete the square to find the restricted domain, or to find the inverse of this function. So first thing I'm going to do is I'm going to fix it first. I don't really want it in this form. I have negative 9x squared plus 54x minus 70. Right, so the first thing I'm going to do is just fix it, put it in a form that I'm used to seeing. And then after that, I'm going to isolate the first two terms. So I want to complete the square because I want to put it in a vertex form because it makes finding the inverse a lot easier. So I can factor out that negative 9, and I'm left with x squared minus 6x. Since I'm completing the square, I'm going to have a blank. And this blank is going to be that middle term divided by 2 is squared, so it'll be plus 9. So I put a 9 in this blank. What I'm really adding is a 9 times negative 6. So I'm putting in a negative 54 into this equation. I need to make sure I zero out my equation. I don't want to change the value of it. So I put in, negative 81. I put in negative 81. I have to put a positive 81 to balance it out. Does that make sense? From here, factor out that parentheses, you get x minus 3 squared, and you get positive 11. So f of x will equal negative 9, x minus 3 squared plus 11. So really, that's the first step I would do to find the inverse. And once you find the inverse, what we're going to do is we're going to, we have to restrict the domain because this quadratic right here has a vertex of 311. And something you guys should know is that if a function, if it fails the horizontal line test, its inverse is not a function. And that's why all even functions and all quadratics, we need to restrict the domain. Right, so it fails the horizontal line test. So we're going to kind of cut it apart so that it can start passing the horizontal line test. I'm going to go with the negative part just because it's a little harder so you can understand what's happening. So I'm going to restrict the domain here to negative infinity up to 3. You could do 3 to infinity if you wanted to. It doesn't matter. I'm going to go with the negative part because that's what you saw in your quiz. Is everyone with me? Are we okay? All right. So I'm restricting it to this domain. So now I'm going to flip the x and y to get that x equals negative 9, y minus 3 squared plus 11. I'm going to solve for y, so subtract the 11. Multiply by negative 1, 9. Then you take the square root of both sides to get the square root. It really should be plus or minus the square root of negative 1 over 9. X minus 11 equals y minus 3. Right, so technically, it should always be plus or minus. Anytime you take the square root of a variable, you should put a plus or minus. But because we're restricting the domain, we know which one it's going to be. We know it's going to be the negative in this case because we're restricting it to the negative side. So the sign should match the restriction. You restrict the negative side or you have negative infinity, you should have a negative in front of the square roots. And then just add the 3 over and you have your answer. Y is negative square root of negative 1 over 9, x minus 11 plus 3. And if you really wanted to, like this is a fine answer, but if you wanted to, you can take out the 9 and say you have 1/3 square root negative x minus 11 plus 3. They're both the same exact thing. Both answers are fine. Are we okay with that? Any questions there? All right, so let's go ahead and figure out the domain and range of the inverse function. I think we should fix the notation instead of y, make it inverse. right? So let's figure out the domain and range of the inverse function. So the range of the inverse function is pretty easy. The range of the inverse is just the domain of the original, and we give you the domain, or in this case, we set the restriction for it. It's negative infinity to 3. So it's negative infinity to 3. That's going to be the range of the inverse function. But for the domain, and I was on the quiz, a lot of people miss this. What I would do is, like, you could find the domain of this function, it would work. But I think it's a lot easier if you just go to your quadratic right here, right? We have this graph right here from 3 to 11. Well, the range of the quadratic is 11 to infinity. So the domain of the inverse is 11 to infinity. I think it's a lot easier going from the quadratic and then figuring out the domain from that. So the range of the f of x function is 11 to infinity, right? I put that right here on the right. So that means the domain of the inverse is also 11 to infinity.
It's now 3 o'clock. If you are not with a coach, director, sponsor, or in tutorials with a teacher, you may now exit the building.
Are you okay with that? All right. We're going to confirm this with composition. This is number 22. So for this problem, especially when it comes to confirming composition with a quadratic or any even degree function, what I would do first, I kind of think it was like kind of doing 2 steps for this composition or this checking, is first I would make sure that the restriction matches the sign in front of the square root. Right? I'm told I have a quadratic and it's restricted on the negative side, so I should have a negative in front of that square root. That's kind of the first thing I would do. I'd make sure it matches, and in this case it does. And once it matches, then I'll go on and say, okay, they match. I'm going to change that g of x to a positive, get rid of the negative, and just work with it this way. Does that make sense? So f of g of x is the first one I'm going to do. That's going to be g of x minus 1 squared plus 3. Or in this case, my g of x is now a positive square root of x minus 3 plus 1. Now minus 1 from above, all squared plus 3. So the positive one and negative one cancel each other out, and we're left with the square root of x minus 3 squared. Right, these canceled out, all plus 3, or x minus 3 plus 3, or just that. So that side's going to work. Good. Over here, because like the real math, what's happening is that once you plug in, and I'll show you when it gets there, you end up having a square root of an x squared, and what that really equals isn't like x, it's going to be the absolute value of x, and then from there, that the sign, the absolute value of x can be positive or negative, right? Because we're restricting the negative sides to be negative x, or basically have a negative of a negative, so they cancel out. That's kind of complicated. I didn't want to get into that. So really, the real answer is just not the real answer, but an easier way to go about it is just do the sign matches, right? So if you have a negative restriction, you should have a negative in front of the square root, which in this case we did, right? Like on number 24 in the homework, you have a negative restriction, but it's a positive on the square root, right? So in that case, you don't have to confirm anything. You stop right there and say they're not inverses because the signs don't match. Does that make sense? But in this one right here, because the signs match, it's kind of like the first step. It matches, it's good to go. So instead of kind of dealing with that complicated math of absolute values, you can just say, well, I'm going to change it to a positive. Because it's essentially the same thing. You're just doing it in the beginning rather than kind of in the middle of the problem. Does that make sense? All right. So now I want g of f of x. So g of f of x, the g of x is now the positive square root of f of x instead of x minus 3 plus 1. And f of x, x minus 1 squared plus 3, get that minus 3 from above plus 1. All right, so we're going to start canceling this out. So the 3 and the negative 3 cancel out. So what you get is the square root of x minus 1 squared plus 1. And this is what I was talking about before. We get to this part right here, the square of the square. This is, technically going to give you the absolute value of x minus 1 because this square turns everything positive. So you don't know if x minus 1 is positive or negative, either one. So it technically gives you this. So you have the positive or the negative version of it. But because it's a negative restriction, we go down the negative route. So that's technically what's happening, but it's the same thing as just saying, well, the negatives are going to cancel each other out, so just get rid of it. Right? So from here, the square and the square root cancel out. We're left with x minus 1 plus 1, or just let's confirm the composition with the quadratic. Any questions about that? Are we good? Good. Not inverses. Yeah.
So I don't get why you put a positive.
It's because if I kept the negative there, which we can go through it right now. So I have a negative of x minus 3, right? For g of x. Well, I'll have a negative right here, right? And a negative right here. And a negative right here, right? And then because this becomes an absolute value of x minus 1. So it's really going to be negative of x minus 1 here, right? So what you get is this part. I have this negative right here, negative. This part right here in green, I'm doing green right here. This becomes negative of x minus 1 plus 1, right? That's what you get. So what ends up happening anyways is the negatives cancel out. So you're left with x minus 1 plus 1 anyway. Because when you think anytime, we do this part to show you what I'm talking about. So let's say we didn't get rid of that negative, right? So we have a negative right there, right? So we get the absolute value, negative of x minus 1 squared plus 1, right? So that the square root of a square, that gives you the absolute value of x minus 1 plus 1, right? The absolute value, you can be positive or negative inside of it, right? But because we restricted the negative side, that means we're going to make this negative. Negative of everything inside that absolute value. Or in other words, it's a really complicated way of saying the negatives cancel out. That's why I say just from the very beginning, get rid of it and just make it positive.
So anytime we're given a question that
I would say make sure the signs work first, right? So like the negative side works, right? And matches the sign. So if it matches, then you say you just get rid of the negative and just makes your life work. Like number 24, right? Number 24 on the homework, they don't match. So that one you don't have to do any work. You see, oh, the signs don't match, they're not inverse. Because on 24, if you actually try to do composition, it would work and you get x, but they're not inverses because the signs don't match. Is it that?
if it's like positive,
Same thing. Just get rid of it. It can't be inverses. Any other questions here, guys?
wait, if it's a positive and negative, or if it's a positive and positive, do you make it a negative?
No, because in that case, this would become a positive. It's basically that's basically just make sure the sign from the square root is always positive after checking the sign, right? So if it was like positive restricted, it is positive just leave it. Any other questions? Are we okay? All right. What's the inverse of this thing? And say the domain and range of the inverse. All right. So for this one, we're just going to split the x's and y's first. So if x equals 3 minus 1 over 5 times the square root. Instead of making it 2 minus x, I'm going to rewrite it as negative of x minus 2 or y minus 2. Just kind of put in the form that we're used to seeing, right? We're used to seeing it like a square root 1 over b x minus h. Just keep it in that form. All right, from here, we're going to just solve for y. Subtract the 3. Then multiply both sides by -5. If -5 x minus 3 equals the square root of negative y minus 2. Then you can square both sides. So you get 25 x minus 3 equals negative y minus 2. Good. It would be x minus 3 squared. Then multiply both sides by negative 25 x minus 3 squared equals y minus 2. Add the 2 over. So your y is negative 25 x minus 3 squared plus 2. And let's make it a little more official, a little more, proper, I guess. Instead of y, put f inverse of x. So this function is the inverse of the original, but this is incomplete because this is a square root and this is a quadratic, so you have a restricted domain. So what we're going to do is we're going to go back to the original function and we're going to figure out what's the domain and range of f of x. So for f of x, if I look at it, and really what I'll look at is 3 minus 1/5 of the square root of negative x minus 2. That's what I'll look at. So the domain here is going to be from negative infinity to 2. It is kind of hard to see. What you can do, you can always just sketch kind of like a rough graph of what it'll look like. So if you look at this function, I know for sure that my starting point of the function, of the square root function, is 2, 3, right? It's your HK. So you start from there, and then usually square root functions go up and right. Well, in this one, I have 2 reflections. The negative right in front of the B and the A. So I'm going to go pretty much the opposite way completely. I'm going this way. So you always draw like a little rough sketch of the graph to kind of see, well, what's my domain and range really going to be? So in this case, my domain is from negative infinity to 2. My range is from negative infinity up to 3. Go ahead.
Would it be wrong?
Yes. Because it's a square root function. Square root function, it's already came restricted. So we're looking at the function they gave us, and we're saying what is the domain and range of this square root. So in this case, the square root is from negative infinity to 2 and from negative infinity. It was square root, so it's already restricted because it's basically half a parabola. So you don't get the choice of saying, I want to restrict this side or that side. Saying this is the restriction you would do. Does that make sense? All right. So from here, this is the f of x. So the inverse, or the domain and range of the inverse is just the flip version of that. So the domain is negative infinity to 3. And the range is negative infinity to 2. That's the domain and range of the inverse function. Does that make sense? Any questions about that? All right, just keep going. We're going to graph a function now. So number 39, we have 3 times the square root of 2 minus x, all minus 4. So the first thing I would always do is fix the function to put it in a form that I can actually use. So put it as x minus h and factor out that negative. Get it like this. So 3 times the square root of negative x minus 2, all minus 4. So from here, I know that I'm going to start at 2, negative 4. That's something I saw a lot of people kind of mess up on. They'll get all the right points, but they wouldn't know where they start. You're always going to start at your HK. So you start at 2, 4. But what we're going to do before we do that is we're going to use the parent function to figure out my new table, my new graph. So the parent function, we have 0, 1, 2, and 3. So 0, 1, 4, 9. Right, so this is my parent function table. I'm going to use my transformation rule to get my new XY table. Right, if you don't remember what that's going to be, that's your bx plus h and your ay plus k. So bx plus h and ay plus k is what you use to transform your parent function table into your new one. So in this case, my b is negative and my h is 2. So we have negative x plus 2. And then for my y's, it's ay plus k. So in this case, it's 3y minus 4. So those are my transformation rules. So I'm plugging all my old y's into 3y minus 4 to get my new ones. So when y is 0, I have negative 4. When y is 1, you have 3 minus 4, negative 1. When it's 2, you get 6 minus 4, 2. When it's 3, you get 9 minus 4, or 5. And so the same thing with the x's. It's negative x plus 2. So when it's 0 plus 2, or just 2. When it's 1, it's negative 1 plus 2, or 1. When it's 4, negative 4 plus 2 is negative 2. When it's 9, negative 9 plus 2 is negative 7. So those are my points. And remember, you start at your HK point, the 2, negative 4, that's where you start. And then I have points of 1, negative 1, negative 2, 2. Is that negative 2, 2? 4. Yeah. Negative 2, 2. Negative 7, positive 5. So you start at HK and just follow the points. Any questions about that? Good. All right, let's keep going. We have this function, or this thing. So the graph of g of x is what you get reflecting f of x across the x-axis and do all these transformations on it. So we're going to take f of x, and what we're going to do is we're going to apply these transformations onto f of x to end up back at g of x. All right, to figure out what g of x actually is. So g of x is what you get when you take f of x and you reflect it across the x-axis. The first thing we're going to do is reflect it across the x-axis, which is a horizontal or a vertical reflection. So what that means is that we get, well, before I do that, I'm just going to fix f of x. I don't like having k at the beginning. Negative 6 square root of x minus 4 plus 5. So we're going to reflect over the x-axis. When you do that, that means you have a negative a value. So you're going to multiply the a and the k by negative. So you end up getting is a positive 6 times the square root of x minus 4 minus 5. You reflect it across the x-axis, or you have a vertical reflection. After that, you have a horizontal compression by 1/2. So the tricky part with horizontal compressions or anything horizontally is that you want to take that b value of 1/2 and plug it directly with the x and then factor it out. So what I have is 6 times the square root. That 1/2, I'm going to put it directly with the x. So 1/2 x minus 4 minus 5. And then I'm going to take that 1/2 and I'm going to factor it out. What you end up getting is 6 times the square root of 1/2. It should be a 2, sorry. It should be a 2, not a 1/2. So it should be a 2 because the horizontal compression of 1/2, you plug in 1 over b gives you 2. So you factor out the 2, you get x minus 2. All minus 5. All right, after that, we're going to translate 7 units left and 6 units down. We're just going to go left 7, and was it down 6? Down 6. All right, so we go left 7. What you're doing, remember, inside the parentheses is x minus h. So if my h is negative 7, what you have is x minus negative 7, or you're adding 7 inside the parentheses. Does that make sense what I'm saying? Yes. So we have 2 of x minus 2 plus 7 minus 5 minus that 6. So what we get is 6 times the square root of 2x plus 5 minus 11. and that's what g of x is. That's gonna be your answer. We're good there? All right, now we're gonna grab the cube root function. So just like before, the first thing I'm gonna do is I'm gonna fix the function. So I'm gonna write it as y equals 4 times the cube root of negative x minus 1 minus 2. After that, I'm gonna figure out, well, not figure out, I'm gonna write out my parent function table. That's negative 8, negative 1, 0, 1, and 8, negative 2, negative 1, 0, 1, and 2. That's my parent function table. For my new table, we're gonna do the same thing we did before. I have my restrictions, and I'm just going to list them out and transform my points to get my new ones. So for bx plus h, what we get is negative x plus 1. For the y's, what you get is 4y minus 2. So from here, just plugging your x's into here. When x is negative 8, you have 8 plus 1 or 9. When it's negative 1, you have 1 plus 1 or 2. When it's 0, it's 1. When x is 1, you have negative 1 plus 1 or 0. And when it's 8, you have 32 minus 2, which is, wait, no, I'm the wrong one. Negative 8 plus 1 is negative 7. All right, so those are your x's. For your y's, we'll do the same thing. We'll plug it into 4y minus 2. When y is negative 2, you have negative 8 minus 2 or negative 10. When y is negative 1, you have negative 4 minus 2 or negative 6. When it's 0, you have negative 2. When it's 1, you have 4 minus 2 or 2. And when it's 2, you have 8 minus 2 or 6. So we got to plot these points. I have 9, negative 10, 2, negative 6, 1, negative 2, 0, 2, and 9, or negative 7, 6. So what you get is a graph that looks something like that. And really, the only important points on this graph are these middle three. So those middle three is kind of what tells you what the HK is, what the center of the graph is, and how you're curving, which way you're going. So I don't remember what the test said. It said plot 4 or 3. I think it's 3. But those are the middle. Those are important 3. You need, if we tell you the graph just 3 points, you have to give us these middle 3, not just 3 random points. Any questions about that? Good. Great. So write the equation of the cube root function below. This is the cube root function. So for cube root functions, remember the first thing you should always do is figure out what your HK is going to be. So to figure out your HK, because you need to figure out what's the middle of the whole graph, what we're going to do is I'm going to see the jumps from point to point. So negative 26 to negative 7, that's 19, right? Then 8, 1, 7, and another 19. You want to figure out all your jumps from point to point. And once you have that, what you want to do is see, where do I have symmetrical jumps? So I have symmetrical jumps at these 19s. So what I'm going to do is I'm going to restrict their ends. Or not restrict, I'm going to average their ends. Because it's a cubic function, it's symmetrical around the HK. So you find 2 equal jumps going out. If you average them out, you're going to figure out what your middle is. So negative 26 and 28, you add them, gives you 2. Divided by 2 gives you 1. So my HK is 1, 3. So we got lucky this time. It's on the graph. So H is 1 and K is 3. So once you find the middle of your graph, you have your HK right away. all we need now is A and B. So once you have your H and K, these jumps from point to point don't really matter anymore. So I'm gonna go ahead and erase them. Because what matters now that you have your HK is the jumps going out from your HK. That's what we need to find that first, because we need to figure out, well, what are my jumps kind of going out from HK? HK is right here. So my jumps going out, that's +1, that's +8, that's +27. The other way, that's 8, 27. Or make it less confusing when these pluses is going. All right. So what you're looking for with these jumps going out from the HK is you're looking for cubic jumps. It's a cube root function. So you're looking for cubic jumps of, 1, 8, 27, 64, 125, etc. You want to have cubic jumps, right? Or you could have some kind of scalar of those cubic jumps. So like you could have double them or half them or whatever it is, but it has to follow this pattern of being related to the cubic jumps. So in this case, going out from HK, I have the jumps. I have the exact jump at 1, 1, 8, 27. So that tells me that I didn't change my B. My B is just 1. As an example, if I had something like, let's say 1/2, 4, and let's say 13.5, as an example, I think this is like the cube root one, the top of your page in the homework. I forgot what number it is. Which one is it? 59. Number 59. I think it has jumps like this from HK, which is like 1/2, 4, 13.5. I think one's even 62.5. In this case, it still follows the pattern of cubic jumps. They're just being half, right? This half is half of 1. The 4 is half of 8. 13.5 is half of 27. So that's what it would look like if you had some kind of scalar on top of the B, right? If you had a B that wasn't 1. Does that make sense? Any questions about that? We're good. Go ahead.
What would be
If it was like, like 1/2, 4, what was like this?
yeah, what would
All right, so we should have jumps of 1, 8, 27, right? But instead I have 1/2, 4, and 13.5. So how do I go from these jumps of what I want of 1, 8, 27 to the jumps of 1/2, 4, and 13.5? It'll be half. You divide these by 2, you half them to get these jumps. So your B would be 1/2. Any other questions? Are you okay? All right, so now for the Y's. The Y's are kind of similar. So the Y's, they really match up with the cubic jumps from the X. So X is, when the jump for X is 1, its Y should increase by 1. If the X jump is 8, it should be 2, since 2 cubed is 8. If the X jumped 27, the Y should jump 3, since 3 cubed is 27. And it's going to follow that pattern. It's kind of like the first cubic jump, the Y should jump by 1. The second cubic jump, the Y should jump by 2, and so on. So in this case, look at my Y's. When my X's jump by 1, or I have that first cubic jump, my Y's jump by 2. When I went from 1 to 9, my X's jump by 8, or that's the second cubic jump, my Y's jump by 4. So they're jumping twice as much as they should. That tells me A is going to be 2. Does that make sense? We're good with that? All right, so you have everything you need. Just put into the formula. F of X is your A, which is 2, times the cube root. Your B is 1, X minus 1, all plus 3. Good?
Wouldn't there be like a
Yeah, missing points are okay. So sometimes, like, you could have cubic jumps of, let's say, if we have another hypothetical, you could have something like, make it more confusing, you have like 1/2, 13.5, 62.5. So you could be missing cubic jumps, right? And that's okay, it doesn't matter. As long as you have the cubic jumps in there, it doesn't matter what the order is. Good?
if B was 1/2,
Like this?
it would be 2, right?
Yeah, and you'll be 2, exactly. 2 parentheses X minus 2. Good? You had to put it in. So let's say, here's gonna make another example. Let's say it wasn't 1, 3, let's say instead it was, I don't know, like 3, 6, something like that. Right? So you put it in and then you start saying, well, what are my cubic jumps going out from 3, 6? So you literally just put it into the table and find cubic jumps from that new HK you put into the table. Does that make sense? Any other questions? Are you okay? All right, now the one problem on the review I'm going to do is number 2. A lot of people ask me about this one. So we go ahead and explain it. I think it's a homework problem too that you guys should have done. So for number 2, this table looks kind of weird, but all it really is just really a condensed way of writing your points for 2 graphs. Like this first row or this first column, all it's saying is that for the function f, you have a point -3, 5. For the function g, you have a point -3, -7. That's pretty much what the table is saying. Is a really condensed way of writing points for 2 different graphs. So what we're told here is that they're inverses. If we say f of g of x equals x, that's telling you f and g of x are inverses. So that means their points are going to flip-flop, right? The x and y are going to trade places. So if I want to figure out what a is going to be, what I can do is say, well, for the function g, I have a point 3, a. So that means on f, I should have some point of a, 3. Right? The x's and y's, they flip. So I should have something like this. So if I go back to my table and I look for a 3 on its y row, I have a 3 right here. And when f of x is a y value of 3, it has an x value of -1. That tells me that a has to be -1, so your answer is B. Does that make sense? Any questions about that? That's the last problem I wanted to go over. There's no questions. That's all I have.